So in this video, we'll be taking a look at what cloud native means. I'm sure you've heard this term before since it gets thrown around quite often, but what exactly does it mean for an application to be cloud native? So below, we'll be looking at 8 key features of applications that makes them cloud native. And the first is a microservice architecture. Cloud native applications often use microservice architecture. This is an architecture in which each function or service runs as a separate unit, so either in a domain-driven fashion or based on some other logic for isolating or separating the application components, and this allows for easier scaling and maintenance. The next is containerization. Applications are packaged in containers, which include everything needed to run the application. So this ensures consistency across multiple environments since containers are atomic, so you can be sure that the same application that you run in one environment and its dependencies is the same wherever it is run. The next is dynamic orchestration. Cloud native apps are designed to be orchestrated, so meaning they can be automatically placed, started, stopped, or scaled up and scaled down by tools like Kubernetes or some other container orchestration platform. And then continuous delivery. They adopt continuous integration and continuous delivery processes. What this does is it allows for frequent and reliable releases. So this may be GitHub Actions, Circle CI, GitLab, or many more CI/CD solutions out there. Next, they built for the cloud. They're purpose-built for the cloud. So rather than being adapted for the cloud, cloud-native applications are built for the cloud from the ground up. So they utilize cloud-native resources and services. I'm sure today you see a lot of traditional organizations move their traditional applications to the cloud. While this is encouraged, it doesn't make the applications automatically cloud-native. Cloud-native applications have to be built from the ground up to take advantage of all the cloud resources and do so in a cloud-native way. Next is resilience. So cloud-native applications are designed to handle failure gracefully. So if one component of the application fails, it doesn't bring down the entire system, as will be the case for traditional monolithic applications. Scalability. So cloud-native applications, they're designed to handle increased loads by scaling out using the cloud's vast resources. So in the case of Kubernetes, you typically will have an horizontal autoscaler to scale out your application based on utilization or request overload. And then you can also have that scale back in when you have lesser workload. And then Agile. So most cloud-native development teams embrace the Agile methodology, and this is because the Agile methodology promotes rapid iteration and adaptability. So teams that operate using the Agile development model are often able to iterate and move much faster. So in general, cloud native refers to the design, implementation, deployment, and operation of applications that are purpose-built in cloud environments. So we've seen what cloud native is, and at this point, I must admit it's kind of becoming obvious why you should build your application in a cloud native manner. We will look at some examples or reasons why you should deploy your application or build your application in a cloud native pattern. So the first is flexibility. With cloud native applications, you're not tied to a single technology or to a single vendor. You can use the best tools that suits your need, right? Because it's cloud agnostic. So this means you can port your application from, for example, Google Cloud to AWS or to Azure with very minimal changes. Next, it's cost effective. Since in the cloud, you only pay for the resources that you use. So no need for massive upfront infrastructure investments, as will be the case in traditional application development, where you have to pre-provision infrastructure or maybe set up servers before you even start the actual development of your applications. And then the next is speed. So rapid provisioning and dynamic scaling means you can react faster to market demands. So for example, if you are expecting a large amount of traffic, maybe for a campaign or for a Black Friday event, you can pre-provision or pre-configure, well, not pre-provision, but you can pre-configure your infrastructure in a way that it can rapidly provision resources as the traffic increases, and maybe scale back down as well when the traffic is much lesser. And then next is innovation. So with the ability to iterate quickly, you can innovate and adapt to changing market conditions much faster. And then you have resilience as well. You can quickly recover from failure because cloud native applications are designed to recover quickly from failure, and this ensures high availability. And how they're able to achieve this is through horizontal scalability is one of the reasons. And so as a result of that, if one of the pods, for example, in the case of Kubernetes, has an issue and it's killed, you can most likely be confident that there's another pod that will take over the traffic and serve the request. And then next is global reach. So with the cloud native design pattern, you can deploy your applications in multiple regions across the world, which ensures you have low latency for all your global user base. So for example, let's say you run your application in the US, you're a US-based company, but you also have customers in the Asia Pacific region that you actually want to serve. You can actually deploy your infrastructure or your application resources in an Asia Pacific region and then serve your customers in the Asia Pacific region from the Asia Pacific infrastructure. So that way you ensure that you have very low latency for your users in the Asia Pacific region. You don't have to serve traffic for that region from the US. And then competitive advantage as well. So because being cloud native allows businesses to adapt faster to market changes, and that gives them an edge over their competitors because you can iterate much faster, and that way you're able to have an edge over competitors.